Okay. So in other words, the probability now that I actually have the disease comes out as now 2%. Okay. Now in reality, I can make this more accurate. Okay. I can give more confidence to my result. How? Have a think. How could I make my result more accurate? So at the moment, there's only a 2% chance that I actually have the disease. Okay. Given that I've just tested myself once. What could I do to increase my evidence? What could I do to increase the chances of me being confident in whether I have the disease or not? Exactly. I go to the doctors and I get them to do another test, okay? So how would my probability tree change? How would my probability tree change? Well, all that would change is now my prior probabilities, okay? Because instead of it being 0.1% and 99.9%, so 0.1% chance that I have the disease, what's now the chance that I have the disease, given that I've already had one test? 2%, right? So can you have a go at this? Can you find me the probability of A given B? In other words, can you find me the new probability of whether I have the disease, given that I test positive, given that now the new probability of whether I have the disease is 2%? Okay, so it might make sense to draw out this tree diagram again. Okay? Okay, so what is the probability now that I have the disease based on this new evidence? 2%, perfect. What's the probability I don't have the disease? 98%, okay? Now you notice that my accuracy level hasn't changed with my test. My test is still as accurate as it was before, so 95% accurate. So what's the probability now that I'm going to test positive given that I have the disease? Good, because that's the correct result, right? And what's the probability that goes here? 5%, because that's an incorrect result. What's the probability that goes here? In other words, what's the probability I test positive given I don't have the disease? Yep, 5%. What's the probability that I test negative given that I don't have the disease? That's the correct result. Good. Okay? So in other words, if you want the probability of A given B, how are you going to do that? Can I give you 3 minutes to have a go at that for me? So in other words, we've tested it once, and we know the probability that we have the disease, given that we test positive at 2%. Now can you do it again? So do the test again. Take another test. What's the probability now that I have the disease, given that that test comes back as positive? Absolutely. Yeah, so it's still the same formula being applied, but what are the numbers now because they've been updated? Okay, let's do it, shall we? So, all right, let's. What's the probability of A now? So what's the probability that I actually have the disease based on my new prior belief? 2%, okay? So I'm going to multiply by 2%. What's the probability of B given A? What's the probability that I test positive given that I have the disease? So test positive given that I have the disease. 95%, good. What's the probability of B? So in other words, what's the probability that I test positive? Yeah, come on. What's the probability I test positive? So there's two ways of testing positive, aren't there? This one or this one. Is that the whole probability? Yeah, okay, so have you got that? Just multiply these together. Good, so there's one way that way. Okay. Times 5%. Good. So with this one, with the probability of B, you've just got to think, how are all the different ways that I can test positive? Well, either I have the disease and I test positive, or I don't have the disease and I test positive. And you've got to think about all those outcomes, okay? And then you just end up adding those together, because you can have this one or this one, yeah? They're mutually exclusive events. They can't both happen. So this thing can happen, or this thing can happen. They can't both happen.
And they're both in the denominator?
Yeah, they're both on the denominator. So in other words, on the denominator, you'd have 2% times 95%, so this one, or this one, so plus this one. Is that okay?
Wouldn't this cancel or because there is a plus?
Because there's a plus on the denominator. If it was the other way around, if it was on the numerator, absolutely you'd cancel. But you remember you're dividing this by the whole of this. Yeah, so it's not just cancellation. Yeah. Has anybody stuck that in a calculator and got an answer? Is it 98%? 28%. So that's a bit high. Okay. 28%. Okay. Now, again, you could say, well, hang on a minute. Like I've done the test twice. There's still only about a 1 in 3 chance. Yeah, about 30% chance. So what would you do now to increase the chances or increase the evidence of your test? So if you wanted to be really sure that you definitely had the disease, what would you do? You test it again. So what would change in the next iteration? Yeah, so 28% would go here now. because that's your new prior. And what would go here? 72%. And then you just do exactly the same thing again, okay? Now, to save you a bit of work, I've already done that, okay? Done it on the screen, so you can always watch it. Increases to 88%, okay? So if you do the test 3 times, there is now about a 90% chance that you definitely have the disease because they've all come back as positive, okay? But you notice there's still a 12% chance that you might not have the disease, even though it's come back as positive 3 times, yeah? So in actual fact, I've done this for you as like a long chain. So we started off without doing a test at all. We knew that the probability that we had the disease was 0.1%, okay? We then went to the doctors, we got our test, okay? Came back as positive, we knew it was 95% accurate, and the chances that we have our disease increased to 2%. And you're like, well, that's rubbish. Like testing once only increased to 2%. So then you test again, and then that test increased to the probability that you had the disease was 28%. And again, there's still a 1 in 3 chance. Like if you put 3 people together in a room, there's only a 1 in 3 chance of one of them will have the disease, okay? So then you test again. And if you test again, it goes up to 88%. So this is 3 tests now. If you go on to your 4th test, you test again, the probability that you have the disease is 99%. Now it's looking hopeful. And if you test for the 5th time, it comes back that the probability you have the disease is 99.9%. But all you're doing all the time is just updating that prior probability, that prior belief. That's all you've got to update every single time, okay? So every single time you run this, you get a new posterior belief, you get a new posterior ratio. That then becomes your prior belief, okay? Then you do it again, okay? And then that will become your posterior, which on the next iteration will become your prior, and so on, and so on, and so on, okay? Does this sort of idea make sense to everyone? Good, okay.